Imagine you're floating through space. You look ahead and notice a dark circle. At first it doesn't seem unusual, but then you realize the stars behind it look bent, almost as if space itself is being stretched. That's your first clue that this isn't an ordinary object. It's a black hole. Most people think they know what a black hole is, a giant object that pulls in everything around it. But that's only part of the story. In fact, if our sun suddenly became a black hole with the same mass, Earth wouldn't be pulled into it. We would keep orbiting just as we do today. So if black holes don't pull everything in like giant vacuum cleaners, why are they considered one of the most dangerous things in the universe? To answer that, we have to start with something completely different: a star. Every black hole begins as a massive star. For millions of years, that star stays stable because two forces are balanced. Gravity pulls everything inward. The hot core pushes outward. As long as those forces stay equal, the star keeps shining. But stars don't have unlimited fuel. Eventually, the fuel starts running out. The outward push becomes weaker. Gravity takes over. The star begins collapsing under its own weight. For the largest stars, that collapse doesn't stop. The center keeps getting smaller and smaller until scientists aren't completely sure what happens next. This is where black holes begin, and this is also where physics starts asking questions it still can't fully answer. Around every black hole is an invisible boundary called the event horizon. If you stay outside it, you can still escape. If you cross it, you can't. What's surprising is that you probably wouldn't notice the moment you crossed it. There isn't a sign telling you you've gone too far. Everything could seem completely normal. By the time you realize what's happening, there is no way back. And that raises an even bigger question. If crossing the event horizon doesn't feel any different, what actually happens after you go inside? So you've crossed the event horizon, the point where nothing can escape. Now what? Most people imagine you'd be crushed instantly, but that's not always true. It depends on the black hole. If it's a smaller black hole, its gravity changes very quickly over short distances. That means your feet would be pulled much harder than your head. The difference is so extreme that your body would begin stretching. Scientists call this spaghettification. It's a strange name, but it's a good description of what would happen. You'd become longer and thinner as gravity keeps pulling on different parts of your body at different strengths. It wouldn't take long. But here's the surprising part. That doesn't happen with every black hole. The largest black holes behave differently. They're so massive that, at the event horizon, the difference in gravity between your head and your feet could actually be quite small. You could cross the event horizon without feeling anything unusual. You wouldn't suddenly know you'd entered a black hole. From your point of view, everything would seem normal, at least for a while. But someone watching from far away would see something completely different. As you get closer to the black hole, your movements would appear slower. Every second would seem to take longer. The closer you get, the slower you appear to move. Eventually, it would look like you've stopped completely. You'd seem frozen right at the edge. And here's the strange part. You wouldn't feel frozen at all. Your watch would keep ticking. Your heart would keep beating. You would continue falling. So how can both things be true? The answer has to do with time. We usually think time passes at the same speed everywhere, but it doesn't. Near a black hole, gravity is so strong that time itself slows down. Not just how you see time, time itself. The stronger the gravity, the bigger the effect. This has actually been measured, not with black holes, but here on Earth. Clocks placed higher above the ground tick ever so slightly faster than clocks lower down because gravity is a little weaker. The difference is tiny. You'd never notice it in everyday life. Near a black hole, though, that difference becomes enormous. Time for you and time for someone far away are no longer the same. Imagine you fall toward a black hole while your friend stays safely far away. For you, the trip might seem short, but by the time your friend could somehow see where you ended up, years, or even much longer, could have passed for them. It's one of the strangest ideas in physics. Gravity doesn't just change how things move, it changes how time passes. And black holes are where that effect becomes impossible to ignore. But time isn't the only thing that starts behaving differently. Light does too. The closer you get to the black hole, the harder it becomes for your light to escape. To someone watching from far away, the light coming from you would become weaker and redder. Eventually, it would fade from view completely, not because you disappeared, but because your light could no longer reach them. From their perspective, you slowly vanish. From your perspective, you keep falling. It's almost as if two different stories are happening at the same time. Both are correct, and that's what makes black holes so difficult to understand. They don't just challenge what we know about space, They challenge what we think is happening at all. But there's still one question we haven't answered. If you keep falling, where do you end up? Do you eventually reach the center? Or is there something waiting there that we still don't understand? That's where the mystery becomes even bigger. If you keep falling, you eventually reach the center of the black hole. At least that's what our current understanding says. The problem is, we don't actually know what happens there. Scientists call the center of a black hole a singularity. It's the point where all the matter that formed the black hole is thought to be compressed into an incredibly small space. But here's the strange part. Our equations stop working. Normally, physics lets us predict what happens next. If you throw a ball, we can calculate where it will land. If a planet orbits a star, we can predict its path. But inside a black hole, those same equations give impossible answers. It's like trying to divide a number by 0. The math simply breaks down. That doesn't mean the universe is broken. It means our understanding is incomplete. Somewhere inside a black hole, there's a piece of the puzzle we're still missing. And that's why black holes are so important. They're not just strange objects in space, they're one of the biggest unsolved problems in science. To understand why, we have to look at the two theories that explain our universe. The first is Einstein's theory of general relativity. It explains gravity incredibly well. It's the reason we can predict how planets move and how galaxies behave. The second is quantum mechanics. It explains how nature works on the smallest scales, like atoms and tiny particles. Both theories have been tested many times, both work extremely well. The problem is, they don't agree inside a black hole. General relativity predicts a singularity. Quantum mechanics suggests something different must happen. When scientists try to combine the two, the answers stop making sense. It's one of the biggest challenges in modern physics. Some researchers think the singularity doesn't really exist. Others think it does, but we don't yet have the right theory to describe it. Right now, no one knows for sure, and that's frustrating. Because we can't simply send a spacecraft to find out. Anything that crosses the event horizon can never send information back. The black hole hides its biggest secret from the rest of the universe. That makes it one of the few places we can study. So what is a black hole? It's a place where gravity becomes so strong that nothing can escape. We know how they form, we know what happens around them. But once you cross the event horizon, we still don't know exactly what happens. And that's what makes black holes so interesting. We can see their effects, we can measure them, we can even photograph them. But their biggest secret is still hidden inside, and somewhere in the universe, millions of these objects may be waiting, with questions we still don't know how to answer. If you enjoyed this video, leave a like, subscribe to the channel, and let me know in the comments, would you ever want to know what's really inside a black hole?